Space weaves into matter, translucent fabric warps and coils. A 2D flat universe transitions into a glowing 3D cube grid expansion, pulsing outward in 3 directions. Rotation around the grid, expanding nodes trace the triadic growth, slowly zooming out from galaxies, back to sphere glowing in the distance. Stars fade, the sphere pulses once. An easier way to discover the Kavetsky theory is viewing a fish in the ocean. The fish paddles his or her rear fin faster or slow and gains speed or acceleration when viewing a spacecraft in space. This three-dimensional sea is the same way we will view space. As the fish gains acceleration or velocity, it stops. This is the velocity the fish has reached. In space, it's the same way. The engines assert acceleration. Once the ship reaches the acceleration velocity, it can stop in the same manner as the fish in the ocean. The meaning of this illustration illustrates space advance, or space gravitation, as if there were a repulsive force in the body of water, the ocean, or in space that, like the Hubble expanse, is a force pushing the water in the sea or the space body in outer space at a continuous velocity. As the Hubble sphere creates a repulsive push force on the space itself, it is accelerating space. This push force is constant and retains a velocity like any moving object. This push force anomaly is measured in quantum physics to be the same force as energy is needed to make an object move even here on our planet. 2 times the mass weight of the object. With this, we can sum the push force of the sphere creating motion in space. A relative velocity used today is the speed of light. But in Hubble's era, he discovered the galaxies were being pushed away from each other at a constant rate and at a constant speed, 43 miles per second per second. If we use the energy analogy like I mentioned in putting an object into motion, it's twice the mass of the object we want to move. Our Hubble sphere pushes faster light, and the energy or pressure observed by Hubble as well as the amount of push force necessary. To move an object relative to its weight, we can calculate it. It takes twice the velocity of light to maneuver the repulsive force needed to push galaxies apart from each other. That's where we can measure the amount of pressure necessary to cause this action. But unlike our fish in the ocean, it will slow down due to the weight of Earth's gravity. But in space, there exists no measurable weight or resistance to slow our spacecraft traveling in space. So we calculate that if space is expanding due to the push force, our spacecraft will assume acceleration without accelerating more than it has already. But we also know that if our ship has the engine capacity to accelerate faster than light, it can. It is this energy pressure that creates a surfing of the runaway space environment that a ship may assume travel and at speeds greater than the speed of light. And since we have calculated the amount of repulsive energy it takes to make this happen, we can rely on our measurements that a ship having warp capacity will travel at least 450,000 miles a second per second, having reached that velocity.
Hello, my name is Rod Kowicki. I'm doing this video on physics, mathematics. I'm developing a new theory on physics. I've done about 15 years of study and everything. A lot of things keeps coming up. Relativity seems to be the accepted theory. When anybody wants to talk about physics, they talk about relativity. Relativity has a lot of flaws, I hate to say. And I'm going to tell you about one in this video. My name is Rod Kowicki. Thank you.